Bonjour. So we are back, and in this video we will cover a topic that is slightly confusing. I hope you understand. It is not in the book, and I find that not many maths teachers cover this topic. So the topic is on numbers and precision. So let us take a case of a 100 meters race at the sports ground. In the group there are 5 competitors, and after the race is finished, the timekeepers have taken the time and they've sent the results to the announcing room, and from the announcing room they are announcing the timing. So here we go. So suppose this is the result of a 100 meter race. Ashok 14.7 seconds, Bhavya 14.8 seconds, Chintan 15.1 seconds, Daksh 15 seconds, Ishwar 15.7 seconds. So if you heard that at the sports ground, what, if anything, would you think is wrong with that? Ashok 14.7 seconds, I'm not going to say seconds now, Bhavya 14.8, Chintan 15.1, Daksh 15, Ishwar 15.7. What strikes you as unusual in these results? Now, of course, the names and the timings are actually made up, so that's not a problem. What is different here, you see, is this is 15.7, that is 15.1, 14.8, 14.7, and this is 15. Daksh is 15 seconds. Why not 15.0 seconds? Well, you've always been told that 15 is equal to 15.0. Correct? All your teachers have told you that. Well, this teacher, that is me, is telling you that this is not so. So here is the answer to this question. Answer is Daksh is 15 seconds. Why is it not? Why is timing not written as 15.0 seconds? Surely 15 is equal to 15.0. I mean, you're beginning to wonder how can Kimda say that 15 is not equal to 15.0, but bear with me, we will come to why it is not always so. So, this 15 is equal to 15.0 is true only for calculations. So, if you take 2 into 15 and 2 into 15.0 will give you the same answer on your calculator. Or you divide 15 by 6 or you divide 15.0 by 6, you will get the same answer. So obviously 15 is equal to 15.0, but again I specify it is only for calculations. It is not true for measurements. 15 is not equal to 15.0 for measurements, and this requires some explaining, and this is what this entire video will be about. I think I'll keep this video short, or I don't know how long it will be. I've got 4 pages of notes. So why is 15 not equal to 15.0 for measurements? What is different between 15 and 15.0? When I say measurements, these are real life numbers. You are measuring the timings, the time taken to run 100 meters in real life. This is not, a mathematical problem. Of course, we are dealing with units, seconds, which can be subdivided. But if the question was how many people are there in Ashok's family, how many people are there in Bhavya's family, in Chintan's family, so Ashok says he's got 3 persons, Bhavya has got 4, Chintan has got 6, Daksh has got 3, Ishwar has got 4. Now 4.0 or 4 would make the same thing, because number of people in the family, you cannot have half numbers. You cannot say I have 4.5 people in my family. So we are now talking of numbers, first of all, of units that are not whole numbers, like seconds, grams, meters. All of these you could have fractional or decimal numbers, but not in say persons or dogs or cats. So having made that clarification, let's go on. When I say Ashok's time is 14.7 seconds, what do I mean? Ashok's time is 14.7 seconds. What do I mean with that? It does not mean that Ashok's time is 14.700000 seconds. I'm leaving this statement out here. I'm not going to pursue this. We'll come back to this later. So, what is the difference between 14.7000 seconds and 14.7 seconds? So here also I've added extra zeros after the decimal. If I do calculations with 14.70000 and I do the same calculation with 14.7, I will get the same answer. But still, I'm saying it does not mean that Ashok's time is 14.70000 seconds. There is a difference between this 14.7 and this number. And to find out why, let's take another example. For the moment we leave it. So similarly, as I say that 15 is not equal to 15.15 is not equal to 15.0. Similarly, I am saying 14.7 is not equal to 14.70000 or even 10. 14.7 is not equal to 14.70 seconds. I'm covering these 3 zeros, and only 14.7 is there. So, before I give the explanation, or to explain it better, I'll take another example. So why not? Let's take another example. So let's find out the distance. If I ask you what's the distance by road from Pondi to Chennai? If you go from Pondi to Chennai by road, what is the distance? So if you look it up, you will find that Pondi to Chennai road distance is 151 kilometers. If you're interested, this is via the ECR. ECR stands for East Coast Road. That is a road that runs near the coast all the way to Chennai. There's another road which goes inland and then follows a national highway. That distance is slightly more. Okay. So this distance is 151 kilometers. Okay. Nothing controversial about that. Nothing wrong about that. 151 kilometers. Now you know that 151 kilometers is equal to 151,000 meters. So, this is the Greek prefix for 1000. So this is 151,000 meters. Which if I turn it back into kilometers, is equal to 151.000 kilometers. Okay. So I've gone from here, I've gone to meters. If I go back to kilometers, it comes to that. But again, I'm going to show you, let me get this in focus. I'm going to show you that this is not equal to this, that this is not equal to this, therefore this is not equal to this. I'm using these terms a little loosely, equal, because obviously if you use these numbers in a calculator, they are equal. If you do any calculations with them, they are equal. But what I mean is, we're coming to a concept of precision. Let's take this. So if you say that the Pondi-Chennai road distance is 151,000 meters, 000, how can you be so sure that it is exactly this many meters? What about 151,003 meters? Anyway, where is Pondi, where is Chennai? What is this distance? Where have you taken from? In Pondi, where have you started? In Chennai, where have you started? Pondi is quite big. It is 3 kilometers, 4 kilometers long. Chennai is even bigger. It's 20-30 kilometers long. north-south. So from which point to which point are you going? So let's say you say, oh, okay, no, Pondi, by Pondi I mean we start from outside the ashram gate, and Chennai, let us take, we go to the railway station. And then you tell me this distance is 151,000 meters exactly. Okay. But the railway station in Chennai is a big place. So where in the railway station are you meaning that the distance is 151,000 meters? So you say, oh, okay, let's take the entrance of the railway station. Okay, I'll let it go because even there the railway station, entrance of the railway station is several meters wide. So you really don't know where you're going from. So that leads me, so this is what does it mean that distance between these two cities is 151,000 meters? To the nearest meter, that means it isn't 151,001 meter or 151,002 meters. No, obviously it isn't. When you say it is 151 kilometers, you are saying that it is essentially not 150 kilometers and not 152 kilometers. It's somewhere in between, so that's why you're saying 151 kilometers. I'll repeat that statement because that gives you a clue to the solution. Solution to what? Solution to the fact that this is not equal to this in real life when you are doing measurements. So, when I say it is Pondi to Chennai is 151 kilometers, then essentially what I am saying is that it is more than 150 kilometers, it is less than 152 kilometers. So let's draw a number line. So essentially what you are saying is 151 kilometers is an approximate distance. So all measurements are approximate. You can go as precise as you like, but eventually you can make them more and more precise, but every single measurement is finally an approximate distance. So suppose I take a scale and I measure from this point to this point and I get something. What does it mean? Whatever, if I say, oh, from here to here is 111 millimeters, how do I know it is exactly 111 millimeters? My scale might be wrong. My scale is made of stainless steel. During hot weather, it expands slightly. That you have been taught in your physics class. Most materials expand when they are heated. So that means it'll give me a different reading in summer than in winter. So already that is an approximation. Secondly, it was made, the scale was made in some factory. Maybe they made slight errors. Who knows? Maybe I'm not looking properly, I'm moving my head side to side and I'm getting an error there. So everything is an approximation when it comes to measurement. Okay. So exactly as I said earlier twice, it simply means that the actual distance, I'm putting actual in quotes because what it actually is also debatable, is more than 150 kilometers and less than 152 kilometers. So, just to make it clear, the actual distance is more than 150.5 kilometers and a less than 151.5 kilometers. If it was less than this suppose it was 150.4 kilometers, I would say instead of 151, I would say it's 150 kilometers because 150.4 is closer to 150 than it is to 151. Similarly, if it was say 151.7 kilometers, then instead of saying 151 kilometers, I would say 152 kilometers. Okay, so we can actually show this by drawing a number line. So we know what's a number line? Dhruvat Gradue, where you put all the numbers. So this is my Dhruvat Gradue for this. I've expanded it. My 0 is way to the left here. So this is 150, this is 151, this is 152. By saying this, that the Pondi to Chennai distance is 151 kilometers, what I'm saying is the true distance or the actual distance is anywhere between this and this. Anywhere between 150.5 to 151.5. So suppose it is here, I'm still approximating it as 151. Suppose it is here, true distance, I'm still approximating it as 151. Suppose it is here, I'm still approximating it as 151. Suppose it had been here, then I would take this to be 152 kilometers rather than 151 kilometers. So actual distance has a range of 1 kilometer from 151.5 to minus, if you calculate this range from here to here, that is 1 kilometer. So actual distance can vary between, for 1 kilometer, when I tell you that the Pondi Chennai road distance is 151 kilometers. But suppose you were told that the distance is 151.0 kilometers. 151.0 kilometers. Let me draw a box here. Now, in number terms, this is not any different from this. If you do calculations, you will find the same results with this number or with that number. But now what I have done is I have given you a little bit more precision. I have added one more digit after the decimal. So in this case, the precision is to the nearest 0.1 kilometers. It is not, which is about 100 meters. 0.1 kilometers is 100 meters. So in this case, the precision, the range, here it is 1 kilometer, here the range is just 100 meters. And if I draw the number line again, I kept the same scale just so as not to confuse you. There is 151, there is 150.9, and here is 151.1. And this goes from here to here. This is the actual range. So it will be 150.95, that is this point. And so the actual distance is greater than 150.95 and less than 151.05, which is this distance, which is this point here. Okay. So the range is, I'll just draw a little line there. The range is between this and this, so range is 100 meters. Now suppose the actual distance was here, 150.8 say, then we won't say it is 151.0, we would say, sorry, if it was 150.92, let's say it was here, 150.92, then instead of saying it was 151.0, we would say it is 150.9 because it is closer to that. So here the range was 1 kilometer. Between this distance and this distance, we were approximating it as 151. With this, because I am using more precision, just by saying that the distance is this, the actual distance has to be between 150.95 and 151.05. So you see here it was actual distance was 150.5 and here it is 150.95. Here the actual distance was 151.5, here it is 151.05. So here this thing has become considerably narrowed. The precision has increased to 100 meters. So the range is only 100 meters. So what is meant by range? Again, it says the variation that could take place and still be called 151.0 kilometers. Here the variation that could take place and still be called 151 kilometers is 1 kilometer. From here to here is 1 kilometer. Here in this case, from here to here is 100 meters. So 151 kilometer is less precise than 151.0 kilometers. Even though both of these numbers are the same in terms of calculation, 151 kilometers is less precise than 151.0 kilometers. So, if we come back to Daksh and his 100 meters time, what do we get? We said it was 15 seconds. We'll do the same number line. If we do the number line, then his timing anywhere between 14.5 and 15.5, I would say is 15 seconds. You see? Whereas his classmates, for his other group mates, I was saying 14.7, 14.8, 15.7. There I was using more precision. Here I am using less precision. So, to be consistent, so that means his time was any time between 14.5 and 15.5 seconds, and I would say his time is 15 seconds. Whereas if I said his time was 15.0 seconds, which would also be consistent with the precision of the other competitors' times, because I'm taking one digit after the decimal, then it would mean that again, if I do the same drawing, that his timing is between 14.95 and 15.05, and that leads to 15.0 seconds. So zeros at the end of the number after the decimal, in some cases even before the decimal, but we'll ignore that. So zeros at the end of the number after the decimal change the number for measured quantities. I'm putting change because in some cases, some ways it doesn't change for calculations, but otherwise it does change. So again, some examples. 23 meters is different than 23.0 meters. 26.06 grams is different than 26.060 grams. Here I am defining it more precisely. The range of the actual number, the actual mass, is less here than here, which is itself different from 26.0600 grams. This is 10 times more precise than this, which is 10 times more precise than this. Okay. So let's take another practical example. Let's say distance from Chennai to Pondy is 151 kilometers. I take 2.55 hours to travel it. What is my average speed? So you divide 151 by 2.55, you'll get kilometers per hour. Vitesse est égal à distance sur temps. 151 divided by 2.55, you get 59.215686 kilometers per hour. So, does this make sense? No, it does. The number is correct, of course, because we did that on the calculator. But it doesn't make sense to have so many digits after the decimal, because you didn't use precision here. Here it is. Here, as we saw, when we say 151 kilometers, it can be anything between 150.5 and 151.5. So actually you should do this calculation with 150.5 and 151.5, and then do two calculations and see the range of the speed also. The range of the speed will vary considerably. We won't do that, but we will just see that instead of writing so many digits after the decimal, it would make more sense, since the precision of the distance is low, 151 kilometers only. No, it is to the nearest 1 kilometer. It is meaningless to use so many digits in calculating the speed. It would make more sense to simply write 59.2 kilometers an hour. Okay, now this is the sum of the video for today. I'll give you, I didn't write down some problems, but I want to say, let's say, I'll give you only one problem. I want you to draw the number lines, and calculate the range of, let's say, two numbers. So let's say one I guess 26.01 grams and the other one is 26.010 grams. So these two are numbers. This is more precise than this, even though both numbers are the same as far as calculations are concerned. So I want you to draw the number line for these two, and I want you to calculate the range for these two. You can, this exactly. Three things I want you to do for each one, for that. One is to write it like this. actual mass, because I've used grams. One is to use that. The second is to draw the number line and then to write this range here, actual mass, anywhere between that and that range, and then do the same with the other number. You can of course expand this because I'm using already decimals here, 26.01. so you can actually draw something like this, 26, and you can draw here 26.1, and here you can draw 25.9, and you can do it that way. Yeah, so 26.01 will be here. Actually, you may need to draw a little bit more expanded than that. Anyway, let's see. No, don't do it this way. Let me think. Make it a little easier for you. You mark 26.01 there. You mark 26.02 there. You mark 26.03 there. Then what will you get here? You'll get 26.0. Here you'll get 25.99. Yeah, don't draw that. That's wrong. Draw this. Sorry, I wasn't. Do it like this. You will see that the answer will be centered here. In one case it will be wider, in the second case it will be narrower. Okay, this is the only thing I want you to do to this. I told you it will be a short video, but it's almost 30 minutes. So I'll stop here. If you like, you rewatch this video from beginning to end. As always, you can slow down, you can fast forward, you can speed up, any which way you like. I'm going to stop here.